Okay, here we are, guys. We're in the very last exercise of the compressor lab for the LogixPro RS Logix simulator for Allen Bradley. This one is interesting because there's not a bunch of set things that you need to do. They're like, well, you could try this or maybe try that or see what works out best, but there's not like real definitive goals you need to achieve. So it's kind of confusing. There's lots of questions, and it's going to make it real hard for me to grade because I'm sure everybody did it completely different, and I'll have to spend a long time seeing which compressor is doing what for each individual one. Anyway, we'll get right into it. So I'm continuing from exercise 3, which I have a video on how I did exercise 3. If you're wondering how I got to this state, here's my output lights. Here is my flipping for my alternating bit. Here is my motor rungs to allow my motor outputs to be true or energized. And then in the last exercise, we added this second pressure switch. So when the load is too much for one, it'll enable this heavy use bit. And that will bypass the alternating bit. So I think I'm going to start at the bottom where it says here. In order to monitor how well your system is working, provide a means to display the accumulated runtime for each compressor. Utilize both the panel-mounted selector switch and LEDs for this purpose. This is one of the few sections in this exercise that's real specific about what they want you to do. So I'm going to come down here and add some extra rungs. And it's kind of a pain here to add extra rungs because it doesn't just stay where you put it, and then it wants to add rungs different places in the program. Let me see, that might be enough. Let me do one more just to be safe. So what am I going to do here? I'm going to display the runtime for each compressor using the selector switch and the LEDs. So they mean this ABC switch, and these, they're calling these LEDs, but they don't really look like LEDs. So what I'm going to do is each time one of the motors are enabled, I'll have it increment an RTO timer. I'm just going to drag some stuff down here a while. So motor 1, whenever motor 1's energized, it'll run this timer. When motor 2 is energized, it'll run this timer. Call that the motor. Oh, because I didn't address them yet. Yeah. Let me put some addresses in there. I don't think I have any other timers in here, so I can make that first one T40 and the second one T41. There we go. Motor 1 run on timer, motor 2 run on timer. We're going to have to set the presets to something real high so they don't time out. And we can set them to 9999 because that's how high up we can count on that display. And after that, they'll have to go down for a PM or something. I mean, I think we could set them higher than that, but it would just, I'm not sure what the counter would display. We know it'll go up to there though. And time base, okay, all right, looks good. So when motor 1's on, this timer is going to keep counting. When motor 1 goes off, it'll keep the accumulated because of a retentive timer, and then the next time it comes on, it'll continue counting, so you'll get your run hours saved in the accumulated of T40 for motor 1, and the same thing goes for T41 for motor 2. So now we need to be able to select which one we're looking at up here and have it display. So we are going to have, let's see, what are these inputs? So it says input 4, input 5, and input 6. It's going to be input 4, and that's going to be input 5. Wait, let me see exactly how these were addressed. Input 1/04. I got my inputs. Input 1/04 should be this guy. And input 1, 0, what are we getting? 5? Don't know why that got drugged down there, but okay. Input 4, input 5, and they are going to enable a transfer of the accumulated to the display. And that is going to be here. No. There. TOD. And our source is going to be the accumulated. Our destination, let's put our destination because it'll be the same. If we hover over there, we see it's output 4. So our destination, we can put capital O colon 4, enter. These descriptions are acting real weird. Blank them both out. Okay, I can take blank. That's all right. So they're both output to our LED, and now we need to make the destination or the source the accumulated of these RTOs. So we are going to go to timers, T40, T40 accumulated. This is going to be the motor 1 runtime, and T41 accumulated. Be there. So now, if all goes well, anytime motor 1 runs, it's going to increment T40. And when I flip the switch here to A, which would be input 1/4, it'll close this and it'll transmit T40's accumulated, which is the runtime of motor 1, to output 4, which is this LED. If I switch this switch to B, this will go false, this will go true, and then it'll be transmitting the accumulated of T41 to output 4. So then I'll be looking at motor 2's accumulated. That should work. Let me just download it and double check that that is what's going to happen here. Let's go down and look at this timer. Okay. Motor 2 is running. Motor 2 contact here is true, which is enabling this RTO. That's why it's counting up. And you see the accumulated down here in this transmitter. If I go to B, there you go. So there's my display. And it's displaying the accumulated value of the timer that runs when motor 2 is running. So it's really 36, 37, 38 seconds is the amount of time that's been running, because the time base on this is in tenths of a second, and you can't change it in LogixPro. You can change this time base to different things in real life, but in LogixPro it's stuck at tenth of a second. Okay, so we got this part done. In order to monitor how well your system is working, provide a means to display the accumulated runtime for each compressor. Utilize both the panel-mounted selector switches and LEDs for this purpose. So that's one of the only things that is really set in stone that they want you to do in this exercise, and that's taken care of. I guess I could label those. Let me go offline here. So this is just true when you have this switch pointed to A, and this is true when you have this switch pointed to B. And again, that just directs where that display up there is going to get its data from. It's either going to get it from that runtime, retentive timer on, or that retentive timer on. So that's good. So basically, they want you to keep it the same way so that if it is losing pressure and it's going below 98, that both of them still come on. But it also doesn't want one to run for a really long time. Like, let me download it and give you an example. If you get it right around 80%, well, I gotta wait until it goes back to a single. Gotta wait until it goes back to a single compressor for you to really see what I'm talking about here. So I'll let it pump up to 120 quick, and then I'll increase the outflow so it drains down a lot faster. And then we'll see when it's pumping on just one compressor, I'll show you what they're trying to avoid. And it's kind of not a very good explanation, the way it's written out here, especially if you're not familiar with air compressors. Here we go. And bam, we have one compressor. Now if we go down, so see how it's slowly climbing at 1/10 of a psi? If you increase the percent flow out of the tank, now it's increasing even more slowly. Now it's just barely. So this compressor is only barely making more pressure and more air than is being consumed by the plant. I'm going to let it pump up a little bit above 100 because I don't want to trip this other pressure sensor. But if you put this about 80, it'll sit here for a really long time. So this is the idea that it's trying to avoid, and I don't feel like it did a very good job explaining what problem you're trying to solve here. So it's at 1 at 3.4 psi. If you're using 80% flow coming out of this tank, it'll pretty much sit here forever because it's not making enough to increase the pressure in the tank. And it's not making so little that it's going down to the point where it's going to trigger the second compressor to come on. It's just going to sit there. It's making the exact same amount than is being used. So it's going to sit there and just run and run and run and run forever. As long as the airflow out matches the airflow in, it could just run indefinitely in this state. So that's what you're trying to avoid. My first solution that I thought of was, well, I'll just put a timer on there. So if either of these motors are running for more than, I think I said 80 seconds. I figured it out. It takes about 50 seconds normally for one of these to pump back up. So if it goes 80, then it's not really keeping up. And that's just something I determined on my own. Like, it doesn't have to be 80 seconds. It's not set in stone. It just seemed about right. So if either one of these is running by itself for 80 seconds, then I just have it to trigger this same heavy use bit. So they both come on and it pumps all the way up to 120 with both of them running. And that also does not affect my alternating bit. So then the next time when one of them comes on, the other one that wasn't running for 80 seconds will be the one that comes on. That's what I'm going to end up doing here. So I'm going to stop this. Let's just switch back and forth and see. They're not super close, but I would imagine A was doing in the middle towards the end of another cycle, and the next time B came on, it probably would have caught up and been close to the same amount of time. So let's go offline here, and I don't have too much really to add to get this to do what I want it to do. I'm going to add some more rungs just to give myself some space and to make it easier to follow what I'm trying to do here. And nice with LogixPro, you can download to the processor with empty rungs, which you can't really do in real life. So I am going to bring one of these guys down. I'm just going to make a parallel here that says if either motor is running, it's going to energize this timer, and I'm going to use a TON timer so it automatically resets. And I'm going to make it, well, I got to address it. I think I'm on T42. I like to do it this way so I know I didn't address it wrong. T42, and then my preset's going to be 80 or 800 in this case for 80 seconds. And I'm going to put this here. And I'm going to get that done bit from which timer? T42. I think that might be all I need to do. Let me check here. Let me look at this logic here. This is going to be, or let me call it run on. So I'm going to call this the run on bit, and this is the run on timer. If either motor is enabling this timer for 80 seconds, you'll get your done bit because the timer will time out. Your accumulator will reach your preset value. When that done bit closes, it'll go through and make sure that both motors are on until it pumps all the way up to 120. And then it will kill the PE1 here because it'll be at 120. And once PE1 drops out, both motors will shut off. When both motors shut off, your TON won't be enabled anymore and it'll reset to 0 automatically. So this should do everything we need. Let me download this. Go to run. I'm going to turn this down so it pumps up. Because it was below 98, they're both on right now. That was my heavy use bit down here. We can come down here and look at our accumulated values to see what our run times are. They're pretty close. They're within 700, which is really 70 seconds in this case. So they're not like, one's not like 10,000 and 150. Let's see here. I'm going to crank this up so it'll go down below 100, or below 100 here. Oh, going the wrong way. Okay, so it's kicking on. I got one that's running, and I'm going to slow it down, or increase the output flow to about 80. So this compressor will not be able to add pressure to the tank. And if we look down here, we can see our, where is it? Or up here, run on timer. So if either of these motors are running for more than 80 seconds, which it's timing right here, we'll get our done bit. Oh, you know what? I have an even easier way to make this work, but I'm just going to double check this is going to work the way that I think it will, and then I'll clean my code up here a little bit after this thing times out right here. What I'm going to do is make a rung around this PE2 and put the done bit in there. So that's just going to enable my heavy use bit, which is already in there. So that'll just make this look a little simpler here. Be a little less rungs and a little less code. Okay, my timer timed out, and now both motors are running. You see my pressure is rising. It's going to go up to 120. And once it goes up to 120, they'll both shut off. When it gets back down to 100, the one that wasn't running before, it'll have alternated again like it normally does, because that bit will still have changed up top, the alternating bit, to the opposite motor. So not the motor that was running for 80 seconds, the other one will be the one that comes on the next time when it starts. So they'll distribute the load pretty evenly. See, the accumulated are both at 2100 for the two different timers that are measuring the amount of time that they've been running. You can also see it up here, 2250 and 2130. So they're both pretty close, pretty evenly sharing the load. So that's all functional, and that's pretty much the end of the program. But I was just thinking as I was looking at it, that it would have been cleaner to me, it would have been nicer looking if I will put this down here, put that there, and put that there, and now I can delete this. Actually, I'm going to use my keyboard to delete it. And delete this, and delete that. Yeah, so basically now I'm just using this run on timer to enable that heavy use bit that kicks both of them on, instead of having another redundant set of two rungs that is also on a different bit. I'm just enabling that existing bit. So I just added these two parallels for the two motors and this TON, and every time that the motors both kick off when it pumps up to 120, this TON automatically resets, so you didn't need to have a reset anywhere for it. And that's that. That all looks good. Hopefully that's helped.